So you all might be thinking that, well, I'm taking sessions in shots because we are a little behind schedule. We were supposed to complete this stuff, so that's why I have to speedrun. So yeah, that's how it is. So if this is 0 and this should be multiplied to this, so anything multiplied to this is 0. I told you right here, x into 0 0. So anything multiplied to 0 is 0. So this should be 0. So total thing is out of the picture. Now this is derivative of two functions divided by del y. Then I told you two functions when they're subtracted or added and taken derivative altogether, then it means like here del by del x of f of x plus g minus g of x equal to del by del x of f of x plus del by del x of g of x, which means taking the derivative of whole thing like added two functions is same as separately taking derivative of the functions individually and just adding them later. So it's what I'm saying. So we can take the individual derivatives. Okay, that's what I want to say exactly. So individually, let's take derivative. So first things first. First, let me. So 1 into this is say that only, right? I told you anything multiplied by 1 is 1 because 1 is multiplication identity. So let's. So only this term is there. This is 0. This whole term. This is 1. So this got multiplied and same stuff. So this and this only remains. Okay. Now what happens is del. So I also told you that we can separately do the derivatives because derivative of whole stuff like addition or subtraction, we can just individually do the separate derivative and just add them. Like derivative of d by dx of f of x plus g of x equal to d by dx of f of x plus d by dx of g of x, which I told. Okay. So now let's go for it. Cos h2y by del y minus del of this cos 2x. Okay. Cos 2x by del y by this square. Whatever this is. Cos h2y minus cos 2x whole square. Now, what the problem is, this is other term. So, what did I say is, cos 2x, let me draw the line. Cos 2x is a constant because it is cos 2x, x term. But this is with respect to y derivative. So, with respect to y derivative means y is taken derivative. Others are constant if alone and coefficient multiplied with y term. Is cos 2x multiplied to any y term? No, it is standalone. Standalone, it is a constant. And what did I say? Derivative of constant equals 0. This term is 0. Have fun. Now, only this term remains. Now, derivative of cos h2y by y. Now this is going to be complicated because in cos h2y, it's not cos hy, okay? So this is not, this is a nested function. So there are two functions, cos h2y, which means this is f of u, and our u is 2y, and this is the y, where u is equal to f of y. So 2, so this is nested function. So now what happened is the function we need is inside another function. Y is a function of 2y, and that 2y function is inside another function which is cos h, whose derivative we are taking. So our y function is there, but it is inside another function that is packed inside another function. Like it is like packed in a box, then there is a smaller box, then there is a smaller gift which we want. So it's like that. So there are so we need derivative of y. That is f of y. Okay, if it was cos h2y, no issues. This is cos h2y. So there is 2y is our f of y. We need to take derivative of f of y. Okay. But now, this is not 2y. This is, even if 2y or cos 2hy, it would have been done derivative. But this is 2y, y became 2y, and 2y is a function of cos h2y. So this is a nested function. What did I tell you in nested double function? I told you, see, f of u is u is f of x, and x we have to take derivative. So what we have to do is chain rule. Outside function derivative multiplied by inside function derivative, dx of f of u, first take f of u derivative, then multiply with f of x derivative. So first do cos h2y derivative, then do 2y derivative, and multiply them, okay? So, cos h2y